are you? I hope you're doing well. How am I doing? Oh, let's not go there. I have coffee right now. It's 7:30 a.m. and I'm filming this video this early because several people in the last few months I have met in person and they've been like, "Oh my God, I love you. I watch your videos. Like, why the hell did you stop?" And I'm like, "Oh, thanks so much. That's so sweet. The PhD has been hard." And then they want none of it. They want none of it. They don't care, which is fine. I understand because everyone in this world we're all just living it and then we're going to die. They were like, "Oh, we'll just do like one video a month. Just one video a month." And I'm like, okay, I'll try. I'll see what I can do. So this is my attempt at one video a month. However, everything I do is like a little overboard, and there's two folds to this, right? On the one hand, I take everything too far, right? Like, I'm a perfectionist. This video is not going to be perfect at all, but I take everything too far. On the other hand, I have a year's worth of footage about this stupid sensor. I think even over 2 years worth. I have been sitting on this footage for, as I said, over a year, and I just don't know I don't know how to move forward with YouTube because I have this footage, I have to edit it, I have to upload it, and then I can move on. But because it's like an hour's worth of footage, I never have the moment to sit down and edit an hour's worth of footage. Why don't I have the time? So as you know, I was like pretty consistent with YouTube posting, pretty consistently for 3 years, you could say. And then I started the PhD. I haven't posted since, pretty much. I think I posted in my first year like 4 or 5 videos, and that was 2.5 years, a 2.5 year chunk of basically not posting anything. So that's where we're at right now. I have a 4-year PhD and I have a 1.5 years left. So that's how I'm doing. That's how the PhD has me in a chokehold, so that's how we're doing. So my attempt right now is I have started to edit this footage and it was too much. I mean, it's an hour's worth of footage and it was too much. So what we're gonna do today is I just dumped everything and made one giant video file, and we're gonna go through it and react to it together because I haven't seen some of this footage, and then we can finally put this year's worth of footage under the rug, and then I can start making like easy peasy vlogs, one a month, so everyone is happy and I can finally let this footage go because I can't look at it anymore. I can't look at it's time to move on. Okay, here we have 58 minutes worth of footage. So let's see what I was up to a year ago. Okay, it's day 2 of quarantine, first day of work. Quarantine. I do look tired because I'm jet lagged. So the last thing in Switzerland that we saw is that my sensor can go to sleep and then every hour wake up. It can take a measurement and it can write to an SD card. However, what I noticed is that when the sensor went to bed, the LED on the SD card stayed on, and I thought that doesn't make any sense. Why would the SD card stay on if the sensor says it's sleeping? And what I realized is that the microchip is sleeping, but because I'm using this development board, actually the development board still has 5 volts running through it. Okay. I don't know why I'm explaining every single little detail about this. It's just like, I'm looking at her and I'm like, you're so sweet, but it's not necessary. So the SD card is still pulling 5 volts. forward.
I just set up an example circuit to demonstrate my point, so bear with me. So here I disconnected my SD card, so just ignore. I took the 5-volt power supply from the board. So right now I have this voltage supply going through my LED to the ground. That's this one here.
Yes, good job.
And then this one here is this signal, so like a switch. So
it's so painful because I feel like I'm talking so slow and like, what is the point? Okay, I feel like I'm just gonna skip this whole part. So basically this was in December 2020 when I was like, I had figured out all of the optical part of my sensor, which was arguably like the most important part of a sensor, of like the actual sensing component. And now what I had to do is I had to make it ready for the field. So I had to make sure that it would like go into low power mode, it could save to an SD card. That was basically it. I just needed to save it to an SD card, have like a clock, and make sure that it went into low power. So that's what all of this is about, and this is like that electronic side of things that I'm not very good at because, or I wasn't very good at because I'm not an electrical engineer. Spoiler, I redid the entire sensor since then. Let's move on. Let's try to find something interesting here. So here I'm just explaining that I used a transistor to cut power to all of my components on my sensor when the sensor went into sleep. Okay, let's move on.
0.
Okay.
In, plug this LED.
Yeah. When I plug it in, light should go on.
Power supply. I am right. And that's what we see. Wow.
Wow.
Super cool.
She said it. Super cool.
So this is the principle. I don't know anything. And just because it is these other pins
Oh my God.
are grounded.
Move on from the transistor.
Going from 5 volts to
I can't get over this transistor. Like, we have to skip this as fast as possible.
ground to transistor versus MOSFET. I didn't know the difference. So that's what I was reading today because this is a MOSFET. This is a NPN transistor.
Yes, I switched from using an NPN transistor to a MOSFET. No, I'm not even gonna explain.
You learn, you work, you learn. You just gotta figure it out. Oh, my Lanta. Yes, I'm still wearing the same sweater. I think it's day 4 of quarantine. Basically, it's snowing. Okay, so why am I excited? Because I just solved a problem. Let me show you. So in my code, I was
Oh my God.
realizing there's no measurement difference when the LED is on and when the LED was off.
Again with the transistor.
Will
Again.
work with another.
Okay,
Right.
the LED goes on.
But then
I'm just showing you here something extremely interesting, which is that my LED doesn't work, and I'm trying to figure out why. Moving on.
through math and going back to my roots with electronics is that
It's like 2 Kirchhoff's law equations. Very impressive. Oh my God. Move on from the LED. This is so painful.
my work for the day.
Maybe it's only painful because I like have been through it and I don't care about seeing it again. Maybe if you guys were watching it, you wouldn't find it painful, but I think you would.
I was so jealous when I woke up this morning and I saw snow in Zurich of all places, and then I came
Show me the snow.
downstairs. Look at that snow. Makes me so happy.
Okay. At least she's precious and we must protect her.
Figured out how to write to a SD card with one code. I figured out how to read temperature and pressure with another code. As you saw in my last clip, I was using a BJT transistor to turn on and off my
LED
Wait.
again. Okay, moving
No.
on.
Like, the next version is just going to be fully functional. It's not going to be optimized at all or beautiful.
Yeah, okay, so basically what I am trying to say here is that I am just trying to take my optical components, connect it to, as I said, SD card, low power, not optimized at all, just so, and then put it all in a waterproof housing, and then put it all in my underwater tests, just so that I can get data. Because right now it's not about making a beautiful sensor, it's just about making it through the PhD. It's not going back to the
This
transistor.
is the circuit
Nope.
board
No,
powered.
no,
I figured
no. Okay, I figured out how to use a transistor, so
turns on. If I go to 5 volts, it turns off. So that is great. The reason I chose P-channel MOSFET and
Nope.
not N-channel LED,
no.
it turns off the LED,
There it
which
is.
requires a P-channel and an N-channel in case I'm basically done with my quarantine. I moved back into my grandparents' house. I'm found my old McGill mechanical engineering sweater, which makes me happy.
So sweet.
This is what I have done so far in these last 2 weeks of quarantine. So this is my current version. That is the turbidity sensor, my SD card, and my pressure and temperature sensor turn on when this.
By the way, this pressure and temperature sensor isn't waterproof, so there's no way I was able to implement it into my sensor.
And what I would like to do is try to run my entire thing on a battery.
By the way, when I designed this system, I was like, yeah, I'll use a 9-volt battery. It's just like, it's incredible how much you learn in a year. 9 volts is pretty useless. Like, it's such a high voltage, and there's no point of using such a high voltage on a system that is essentially a 5-volt system. So it would make way more sense to use like 3 or 4 AA batteries in series, which have a way longer battery life than a 9-volt battery. Doesn't make any sense, but it's what baby Jess decided to do. I just want to say, for context, we're at 26 minutes out of 48, and that 26 minutes was essentially all about transistors.
I also want to implement like a protective circuit, so in case
This was the smartest thing I've ever done, actually.
someone plugs this in backwards, it won't fry the entire module. And the way I read to do this online is with a MOSFET. So I'm gonna try to
I
figure
love
out that
my
circuit,
transistors.
see if I can turn the sensor on and off. Yeah, because I don't know if you saw that one video like a year ago. I worked so hard to basically just solder a bunch of wires to pins, and I went to plug this in and I plugged it in backwards, and the whole thing just like popped and little smoke came out. Very sad moment.
I will link that video right here, or whatever. It was a sad moment, and also quite hilarious.
Oh, looks like I corrupted something because that light should not be on. It's okay, it's okay. Okay, so here's just talk about it.
Here, clearly my grandma's holding the video, and I don't know if you understood that. That was in Russian. She's like, my hands are shaking, and I'm like, it's fine, it's fine. So I get her to hold the video, and then in my quick attempt at putting this footage together, I didn't even rotate it. So you can't even see half of the video, my poor grandma. Okay, this is like the most interesting part. This is the protective circuit. It's a P-channel FET, and it's connected in a special way. And if you plug in your battery backwards, it won't fry your microchip. everything else is not as interesting as that.
When I'm using it works, and it looks really cool in the video screen, the blue light. This thing is still on. Nothing is burning. Let's see if the SD card flat. Oh, nice. Oh my goodness, now I have to solder all of this together. I want to see if it's time to create a printed circuit board. It's
The fact that I thought we should do this as a printed circuit board was very kind of naive. It was naive because this thing had so many problems, and I mean, printing it wouldn't have made a difference.
December, my last day of work before my Christmas holidays. 2 weeks. And what do I realize today?
What?
I realized that I started to think about how I'm going to make the housing for my sensor. And then I started to think, can I just put epoxy over this little dinky little temperature and pressure sensor? Turns out you can't. And I haven't taken vacation all year. Life of a PhD.
Okay, so I would like to note that we are 41 minutes into the video and we have 48 minutes. So basically, let's obviously blame coronavirus because it put me in quarantine, and then I decided to film. And that's why we have all of this footage, and that intimidation is what led me to not edit this video for a whole year. Thank you, coronavirus. So here, I'm pretty sure I wasn't saying anything, but this is my first attempt at soldering everything onto my prototyping board. And I put all of the transistors on the opposite side of the board, which made everything very difficult to solder. You solder, you learn. You live, you learn. You solder, you learn. Not so bad. So that was my next version where I put the transistors on the other side. Okay, so now we're over the audio part of the video. It's just me. Like, I hate vlogging in public, so I'm just like taking out my camera and like doing this. Anyway, so here you can see the sensing head, which is these black solid pieces of PVC. And then the housing is just this off-the-shelf PVC tube, the gray. Yeah, so you can see I have these little inserts, which are the components that hold the lens and the detectors in one cylindrical component to really make sure that the optical part is solid. And then I take that cylindrical component and I slide it into the solid piece of PVC. There, I'm taking it out now. Yeah, so that's the idea of the sensor.
I'm in the lab after hours, so there's no one here.
Which is the only reason I'm vlogging.
I guess it's like, what is it, mid-April, and I haven't done this in a long time. I don't even know if I'm going to this is ever going to make it into a video. But I am now calibrating my new versions of the sensor. This is the tubing, and it goes, like the sensor goes into one of these tubing pieces. And then, like this. So it's completely waterproof.
This calibration that I had to do takes a whole week. It's extremely labor intensive, and you have to use a solution called formazine, which is carcinogenic. And what I found, and what I also argued in my paper, which has been accepted, it's not released yet though, so I will link the preprint in the description below. is that, so what I argue in my paper is that you don't actually need a formazine calibration step, which is great because we don't get exposed to this carcinogenic material, and we save like a week's worth of lab calibration. And if you're interested in how that works, you can read my paper below. First paper of my PhD. Okay, moving on. So here, part of the paper was testing my sensors versus extremely expensive sensors. So here on the upper left-hand corner, you can see I have these sensors from Endress & Hauser. Normally each one costs like 4,000 euros, and they're connected to a data acquisition system. So they can't even be left in a river. They need to be like hooked up at a hydropower plant somewhere with a consistent, where there's consistently a power source available. And then they need like a very special computer built just for these sensors, just to log the data. In the middle, I have my mixer, which is actually just a drill with a paint mixer at the end of the drill. So this is what the experiment looks like. So those are my samples. I'm just shaking them to show you how muddy, how all the different samples have different concentrations. So this is what it looks like once all the sediment settles, and that's the paint mixer there. That's my giant tank. The last part of last year was that I had to test the sensors in a real world setting. So there's like a national park in Switzerland in the canton of Graubünden, and there's a hydropower plant, and every year the hydropower plant releases a wave, like a flood, an artificial flood, and scientists like scramble there to try to measure the flood. So we have like, it's quite funny, like the people that study driftwood morphology, they like stand on the bridge, and every time a piece of wood goes by, they're like, yay, wood, more wood, yeah, wood. So it's, and then you will see what I do. Like while all the people are cheering at driftwood, this is what I'm doing. Flood comes in. Here's a possible location because it's pretty protected. Like there's somewhere to attach the sensor, which is the trees. And it's also pretty protected of like incoming debris. So this is the day of the measurements, campaign, beautiful Graubünden, all of the flowers. I guess that's what I'm trying to show you here.
I'm just in beautiful
I know what happened here. I tried to export the video like the ones I showed you on my phone, and the only way it worked is if I sent it via text message. So that's why the quality is so bad.
Next to the Inn River was up at 4:30 to install my sensors. Couldn't install them yesterday because my battery only lasts 12 hours and the campaign today is 12 hours. So yesterday we're looking for sites. I found 4 different sites on 2 different rivers. I'm now sitting in my rental van eating quiche that my colleague made. Yeah, this is life. So here in an eddy under a tree, we have 2 of my sensors attached to some rebar using some straps. Oops. Yeah, so this is the rock I was on, but my back was hurting a lot. So now I actually
Very interesting.
moved to that little ditch. And other than that, I'm just reading and napping. It's
when I got to this point, I was like, the sensor, you know what? It works for 12 hours. And that's just how it is. It's just something that we're gonna have to accept in this moment in time. Or like in order to make it work for more than 12 hours, I would have to either A, go through and find all of the errors, or B, restart. So spoiler, I am now restarting because it's easier than finding all of the errors. And my current second prototype, that lasts for several months, hopefully, not just 12 hours. So I guess in this context though, you can like decide, like, is it better to be constantly, like, to pay 4,000 euros and be constantly hooked up to a power system, or you can pay 50 euros and you get a sensor that works for 12 hours.
With such a nice view. Thank you.
And with that, that is a great sign off. So I hope you enjoyed this video. I hope you enjoyed my reaction to this hour-long footage so that you didn't have to react to this hour-long footage, because that would have sucked and I don't think you would have watched it. I will try next month to upload a vlog of what I have been doing this month, because I am on, like, I am really stressed. That's why I'm making this video in the morning, because I won't have time any other day to make this video. My plan is basically Friday night to drink an entire bottle of wine and edit this video. So I hope you enjoyed it. I hope you stick around for the next vlog, which will hopefully be out in 1 month, and you'll be able to see my sensor progress on the second prototype. And in case you didn't notice, I also have started to try in an attempt to do science comedy, because comedy is a great tool for science communication. So I've been trying to write science jokes, and they're all very bad, but you know what? You have to start somewhere. Everyone says that your jokes won't be funny for 7 years. So you guys have about 7 years worth of my bad jokes, and hopefully in 7 years I'll be able to write a funny science joke. So please follow that journey. If you have TikTok, you can follow it there, or I will try to remember to re-upload them as shorts on YouTube. So thank you very much for watching this video, and I really hope you enjoyed it. Now I will go to work and I will try not to stress and cry. I hope you have a great day, and I hope you don't cry either. Ciao.